Welcome all of you in the second lecture of the day. And this lecture, so we'll share his expert opinion on this peptides, characteristics and nutritional properties, a case study of reproductive action. So I will request sir to come and start.
Good afternoon, everybody. Welcome back. Let us move to the next session. We'll be talking about the case studies of whey protein isolate. Inherently, I'm using whey protein concentrate, whey protein isolate. So, whey protein concentrate can be 30%, 50%, or 80%, depending on the protein concentration. So, do not confuse any of the terminology. The idea is to have the feeling of how the whey protein works. So, and the nutritional characteristics. The basic principle is that I was talking about evaluating the waste stream, so making gas out of the trash. So whey is basically byproduct of the cheese making factory. So initially, the flow diagram suggests that when the milk comes from the farm, that's the pure milk is maybe organic, depending on the feeding regime. When milk comes, the fat separation takes place. There's a machine called the cream separator. So the fat it goes out cream here. Means you see one of the slides one of the how the milk composition, full fat milk, and the standardized milk. The standardized milk is takes place here, 3%, 4%, or something like that. If you have variation in fat content, it means the milk is different fat, and composition analysis says that you make different fat content. So to standardize it, so you take out the fat at the same concentration, so you get the milk at some desired quality. Then you pasteurize it. The pasteurization is you all know why you are doing pressure cooking. So an example we are doing at home, sterilizing. So deactivate the bulb and denature those. When the pasteurization is finished, the skim milk produced because you have taken out the fat. So the skim milk you have skimmed out, cream separator. Then you standardize the cheese milk. What happens? Standardization means each cheese has ingredient composition. I'll give a classic example of cheddar or mozzarella cheese. It's basically used in different applications. People use that 20 different kind of cheese. So cottage cheese. Cottage cheese has different composition done out of the mozzarella and cheddar cheese. So you can substitute with that cream or SNP, any of the dry milk. So you make solid content increases. Means if you have only 3% fat in your starting material, and your core says you should have 15 to 20% of fat content in your cottage cheese. So how to get into that? So you have to have some of the addition of the material. So that's the standardization here. So then the coagulation takes place. The coagulation rennet is basically for vegetarian purpose. You have to have either acid coagulation. Acid coagulation can be this vinegar, formaldehyde, or acetic acid. Or rennet is basically animal based. So dietary consideration, people will be writing which vegetarian tag is there. They'll write rennet free in that product. So if you are looking in the cell, rennet free. So the coagulation either citric acid or acetic acid. Household they use vinegar. So that's the acetic acid. When you coagulate it, the coagulation will be at different temperatures. Basically, the coagulation occurs depending on the cheese you are making here. I'm not going to detail how this is happening here. Then you have curd. When the curd comes, you apply pressure. So take out the extra moisture, because if you have your product has more moisture, means the cell life will be shut off. But if you have high moisture content, I think Indian standard says a cottage cheese we can revisit and then say that must contain 50% moisture, something like that. Due to more moisture, the cell life will be shortened. So that's the property. So once the cheese is coming, they expand to whey comes out, the unwanted product, the byproduct of the cheese factory, that is going to the water circulation system. So the pollution control board will stop your work there. Either you have to treat that way, then discharge into the water body. So to add means you are losing some of the protein here, some of the other products. So to add value into this thing, the way we design that, you do a precipitation here. What happens here, the way the protein has to recover from here. So ultrafiltration is one way where you membranes are used, the soluble products are separated. Then once the soluble products are separated out, yesterday I was discussing about you start from a concentrated material. Means it's not energy intensive. Otherwise your overhead, the cost will be going over the roof. So it can be spray dryer or drum dryer or any of the dryer. This industry is using spray dryer. Any spray dryer, you can control the particle size. Particle size is a very key material. Like if you have big particle size, I'll give an example. The sugar that we buy from market, fine grain sugar, granular sugar, and the sugar having cubes. You can put in water. The fine granular sugar will disintegrate very easily. The star one time will disintegrate. The idea is that the way protein that you produce, the way you dry it in the spray dryer, the particle size will be controlled. In that way, it is faster the nozzle and all the processing is there. I'm not going into how spray dryer works, but you can control that by the way you dry it. The idea is to get the driver to have various applications and extend in shelf life. The shelf life we discussed basically at room temperature as 20 degree 1 year. The filtration, dye filtration here, it's basically membrane filtration based on the cut of molecular size. So you're using different products to filter it out. When you evaporate it spray dryer, you get around 50% to 80% whey protein concentrate here. So this one is around 50% whey protein concentrate. So this way we can produce the whey protein.
What kind of colors are expected? It's a clear fluid. Or do we expect colors in the whey?
Oh yeah, because basically if you see, sorry for that, didn't highlight that one. If you see normal whey without adding color, without doing any processing, it will be that's a yellow type of yellowish color, slightly yellowish. Some people like maybe my protein powder is yellow in color, people may not buy because I was talking about flavor, aroma, and color and texture. Color people will perceive, like initially buying a chocolate, people look at this is a consumer perspective, they look at the packaging first. That's a packaging is an art nowadays. Like the website, how design a website. So people are spending more money on a catchy website. It's like packaging. So same product is just slightly off flavor, off color. It's not white, so it's yellowish in color. To remove that, you can use hydrogen peroxide or benzyl peroxide. So it depends upon how you are going to use this. People are using that way. So you can have direct without using this peroxide. So it depends on all of you. So you have to write in the code color is yellow. If you receive some of the products from any of the leading companies, then they will give a case and spreadsheet that color is already written there in any of the ingredients manufactured, whether it's whey protein or shea protein, they will tell you.
So per liter yield would be how much? Like if I say 1 liter of whey.
I'm coming to that. That's a very interesting question because I was talking about 87% of milk is water. Bulk is water. We have only 3 to 4% protein. Then you can imagine we cannot, from starting material already 3 to 4%. We cannot increase any protein content out of that. So now this is coming here. So massive protein is milk is a complicated product. Initially I was talking about very simple thing, but it's not like that. Because we are used to our milk, everybody knows it. The kid knows milk but better than us. So this way, this is a simple thing is to make this. You can look at this. This is made here. 87. I have shared a slide before the composition of milk and in the first day introduction to bring out how the milk is composed in a function. So only we have 3% this is fat and 3% protein here. So we have to play in that space. 3% fatty material is only 3% protein. So bulk is water here. The idea is that how to, if somebody will tell our starting material is less here, why you are working the protein? Because we are value adding the product and the way is just wasted there.
This is a composition of cow milk.
Cow milk, yes. Buffalo milk will be.
Buffalo milk is about 6%.
6%.
So in that case, what is the ratio of protein? Does it increase or it's same? In the case of buffalo milk.
Buffalo milk is
having more protein.
More protein.
More protein.
Yeah.
More
So
fat.
6.4% roughly 6% fat, 4.2 or 4.1% protein.
But water is same or
The water will definitely decrease.
it will decrease, other solids has to be same.
Same, yes. Lactose and minerals and constant. More or less. Like if you see, like I will tell everybody is familiar with tea. If you are adding more cream, or the milk containing more cream, so that tastes different. Like buffalo milk tea will be different than the cow milk tea. So you take a sip, so you will feel the difference because due to the cream and the fat present in that, it's not the protein is not giving that flavor because fat molecules